So this is part 2 of hydraulic systems. In the part 1 we covered till hydraulic lock, and in this part we'll be continuing from pumps. If you haven't watched the first part, go ahead and watch it first. The links will be in the description, and get ready with a pen and paper to make your own notes, and let's get started.
Pumps are of two types, hand-operated pumps and powered pumps. Powered pumps are of two types, which is a constant delivery pump and a constant pressure pump. But they're further divided into various types based on how they are being operated. So we have air-driven pump, engine-driven pump, electric pump, ram air turbine, and power transfer unit. Ram air turbine and power transfer unit are also known as your backup pumps, right? And the primary purpose of a pump is to draw fluid from the reservoir. This is your reservoir, this will be your pipelines, and here would be your pump. So what a pump does is it just draws this fluid, it takes this fluid and it sends it to the system. So this is the basic purpose of a pump, that it draws fluid from the reservoir. Alright, so we don't have to study all of these pumps. We'll just go with hand operated and in powered pump, these two type, that is your constant delivery and a constant pressure. So one, two, and three. Alright. So hand operated pump, this is the figure. You can see there is a handle over here, and this handle is moved up and down using your own muscle power. And so these kind of pumps are either the only source of hydraulics in small aircrafts, or they are also used in modern aircraft, but their purpose is limited to ground handling and opening the cargo doors. So, why do we need them in a larger aircraft or a modern aircraft? Is because you don't want that you'll have to start the engine just so that you can open the cargo doors, right? You don't want the pilots to go in the cockpit, turn on the engine, and let the pump build up pressure, and then the cargo doors will open, right? So that is why you have hand operated pumps. The ground crew or the ground staff can just go there, use the hand pump, and open the cargo doors by themselves. So this is a very important purpose of a hand operated pump. Either it can be used in a smaller aircraft, or it can be used for ground handling. And then there is the third thing is it can be used for pressure testing joints and line. So, like, you can have a pipeline here, it can have a joint over here, and you can do is you can just attach your hand operated pump here, and you can just build up pressure in these joints and in this pipeline. So what it will do is you can just test these pipelines for any leakage first thing, and you can also test if it is able to build up enough pressure or not. So you can just close this, and then you can attach an instrument which can measure or sense pressure, and you can then find out if this pipeline is able to hold that pressure. So you can do is pressure testing of joints in line. um, so these are the three purposes of a hand-operated pump. In a small aircraft, can be the only source of hydraulic. In a modern aircraft, it is used for ground handling and opening cargo doors. In general, it can be also used for pressure testing joints in line. All right. And yeah, one more thing, it delivers output on both up and down stroke. What does it mean? It means that even if you're pulling the handle up, it will still deliver output. When you move the handle down, then also it will deliver output. So it gives out output in both up and down stroke. You don't need to go through the working of it because it is not included in the syllabus. Then we have power pump. Power pumps are again categorized into two types, that is constant delivery or fixed volume, and a constant pressure pump. So as the name suggests, constant delivery or fixed volume, the volume will be fixed, right? So volume will be fixed means that I can set a predetermined value for the volume. I can maybe give it a volume of, let's say, 3000 meters cube. So the volume won't change. It will be fixed at 3000 meters cube. But the pressure in this case would not be fixed. It can be 3000 psi, it can be 4000, it could be 5000, it can be 2000, it can be 1000. The pressure is varying, right? The pressure changes, but the volume is fixed. And in a constant pressure pump, as the name suggests, the pressure is constant. It won't change. I can give it a fixed value, say 3000 psi. If I set it at 3000 psi, the pressure will remain constant at 3000, but the volume can be anything. It can be 3000 meter cube, 2000 meter cube, 4000 meter cube, 5000, any value, right? So, what is ideal is fixing a particular pressure, right? Because all the lines, all the joints, all the actuators, all your system components, all of these are designed to operate at a particular pressure, right? They all have a maximum pressure that they can bear. So, for example, I make a system like this, and I say it can bear a pressure of 3000 psi maximum. So, I want to make sure that the pressure remains at 3000 psi. It does not exceed it or go under 3000 psi. Why? Because if it goes beyond 3000 psi, it can cause damages to the system, right? It can cause leakages and damages to the pump and the actuator. But if it goes below 3000, then the services won't be able to operate properly. It won't function properly. Like the actuators won't move properly, right? So I want to make sure that in any system, the pressure should be fixed and it should be a predetermined value. But in a constant pressure pump, it is not an issue because we are already able to set particular pressure. Volume does not matter, right? The pressure is fixed, so it's fine. The system is working just fine. But in a constant delivery or fixed volume pump in this category, you don't have a fixed pressure, right? The pressure is varying. So since the pressure is varying, you need some components to be installed in this category of pump so that you can fix the pressure, right? You want the pressure to be maintained. So the pressure is not being maintained here. That's why you would fix some things in it that we'll see. Some extra components will be fitted in this kind of pump so that you can manage the pressure. In this, there is not an issue. The pressure is already managed by the pump. So we'll see in a constant delivery or fixed volume pump. Firstly, you have is the most common type of fixed volume pump is a spur gear displacement pump. It is just a name. So spur gear displacement type. This is the diagram of a spur gear displacement type. As the name suggests, it has gears. You can see these gears are here, and then there is this thing that it has this tendency to deliver large volume, but at a lower pressure. So the volume that will be given by this pump will be a lot. It will give out a lot of volume, but the pressure at which this volume is coming out will be low, right? This is just a tendency. Again, something very important to remember. And yeah, as I was saying, these pumps they deliver a constant volume and not at constant pressure, right? Since this is a fixed volume pump, the volume will be constant, but the pressure is not. And since the pressure is not constant, it can overload the pump, right? The pressure is again, as I told you, the pressure is not constant, it can vary a lot. And the pressure is varying, but the system is designed to operate at a particular pressure. So if it goes beyond it or below it, then it will damage the pump, it will overload the pump, right? Hence, these type of pumps need to be installed with a relief valve or ACOV or accumulator. This is what I was saying when I was talking about adding some other components to it. The other components are ACOV and accumulator. So these are the two components that are installed in addition to your constant delivery pump so that you can manage the pressure. The pressure is not constant, it is varying, the system can get damaged, right? That is why you install what? ACOV and an accumulator. We'll study both of them shortly, but What an ACOV is, it is an automatic cutout valve, and an accumulator is something that stores a small amount of hydraulic fluid under pressure. So in a constant pressure pump, the pressure is constant, and there are just few points that are very important in terms of DGC exams. That is, the angle of swash plate is controlled by control piston. Again, very important question. What is it? The angle, the swash plate that you're seeing here, this thing, it keeps changing its angle as per the pressure needs. So it changes its angle. It moves like here and here, and it changes its angle, and that's how this whole pump uh, keeps a constant pressure. Like whatever value you set, it will keep that pressure. So this wash plate changes its angle, and how is it being changed is because of this attachment that you're seeing here. It is attached with a piston to a control piston. So it is attached. This is the control piston, and the control piston is fed at what system pressure. This pipeline that you're seeing here, this is feeding what system pressure to the control piston, and that's how the control piston keeps moving back and forth. This causes the angle of the swash plate to change. This thing, this swash plate changes its angle, and that's how it keeps a particular pressure maintained in the system. If I set it to 3000 psi, it won't exceed that. It will maintain that 3000 psi, right? The next point is the entire pump is submerged into hydraulic fluid for cooling and lubrication. So what happens is these kind of pumps, they are having a lot of moving parts. Almost the whole pump is moving. See, these cylinders that you're seeing here, these white colored cylinders, these are all moving. And the swash plate is also not fixed with these pumps. So there is constant friction happening between these parts. And this causes a lot of heat and a lot of friction losses. So what you want is you want proper lubrication. So what you do is you take this whole assembly and then you put it in a case, a case, and then the case is filled with hydraulic fluid. The whole case is filled with hydraulic fluid, and this whole pump is submerged into it. So this thing is done for cooling and lubrication. And if you puncture a little hole through this pump and you drain out some of this hydraulic fluid, so this fluid is known as case drain fluid, and case drain fluid gives a good indication of how the pump is operating. So whatever you want to do with this fluid, you can just measure it, and then you can find out how the pump is operating, how what are the condition of the pump. You can get a proper good indication of this liquid that is that the pump is submerged in, right? These are 3 points, and they're very important. Like, trust me, like you need to remember them anyhow. First one is angle of swash plate is controlled by a control piston. This is the control piston. It changes the angle of this swash plate. Then the entire pump is submerged into hydraulic fluid for cooling and lubrication. And the case drain fluid, it gives a good indication of the pump's condition. Then in system components, there is hydraulic reservoir. So hydraulic reservoir is this thing that stores hydraulic fluid. Why do you want hydraulic fluid to be stored? So the reason is, since no system is 100% leak proof, hence there are always small losses. And to compensate for small losses, we need a hydraulic reservoir. So as we saw that the piston was constantly moving, right? This piston was constantly moving, and there was some seals attached here near the moving part to avoid the leakages. But these seals won't prevent it 100%. There will be still some minor drops in hydraulic fluid. So to compensate for these minor leakages that are okay, that are allowed, and but it will reduce the quantity of hydraulic fluid, right? With time, the hydraulic fluid will reduce, and you won't have enough hydraulic fluid to push or pull your piston. So that's why, to compensate for these small losses, you have a reservoir. This is the first thing why you have a reservoir. Second is the fluid also expands and contracts with temperature. So the fluid that you have here, it is, you might think that it is sufficient, but as you go higher, the air is colder, and this causes this fluid to contract. So it will also reduce in volume, right? So that is why to compensate for this loss in volume, you will need some extra hydraulic fluid with you. So you can just refill it, right, with the help of your reservoir. And the third is that the fluid requirement may vary as the different services are selected. Very common. If you are selecting, let's say, 4 or 5 different services together, and so the demand of the hydraulic fluid will increase. So that's why you will need a hydraulic reservoir to supply to all of these services. And these are the three reasons why it is needed. So in a hydraulic reservoir, these are the few components that you have to go through. The first one is your baffles and fins. So these are your baffles and these are your fins. So baffles and fins, what do they do? They prevent the sloshing and sloshing and foaming of fluid during in-flight maneuvers. So whenever you like maybe take a sharp turn or something, the fluid may obviously it will move here and there. So these fins and baffles that prevent that from happening. The fluid won't move much, it won't create foam. So that is why we have these baffles and fins installed in the aircraft. Then we have is filler cap. Filler cap is this that you're seeing. This is the filler cap. Filler cap does nothing, it's just a cap from where you can fill in the hydraulic fluid. And the filler cap also has this mesh that you are seeing here. That is a small filter so that it can filter whatever hydraulic fluid you are filling in from here. So you just, in order to refill the pump, you add your fluids from this filler cap. Next is your stack pipe. A stack pipe is something that keeps a reserve in the reservoir for the backup pump in case of the main pump failure. Let's say, as you can see, this particular line it takes to the main pump, right? And let's say there is a leakage somewhere here, and all the hydraulic fluid is being leaked from here, right? So this level of the hydraulic fluid is currently this much, and then it will reduce somewhere here, here, then this much will be left, and then it will drop below this pipe. So now what will happen is these this pipeline, this thing would get empty, right? It will completely get empty because the fluid is going from here and it is being leaked out of here, right? This will get empty. But what will be remaining is this much amount of fluid that is here, this and this portion. So all of the fluid in this particular part will be still remaining because the stack pipe, obviously it is taking fluid from here, so it won't take anything from here and the fluid will remain this particular part, and this particular part will be going through this pipeline and it will be sent to the backup pump. So this is how the stack pipe works, and in case of any main pump failure, when it is not able to send the hydraulic fluid to the main pump because of some leakages, there will be still some hydraulic fluid left for the use of your backup pump, right? And then there is an air vent over here. And the purpose of an air vent is to prevent cavitation. Cavitation is what? Very interesting. I'll study what a cavitation is. Cavitation is, we need to look at the two methods of boiling any liquid. So there are two methods. The first one is by heating. Obviously, you have a stove here, you have a vessel, and you are heating it. So the water is getting converted into vapors. You can see the bubbles here. So this is the method one of boiling any liquid. But there is another method which we can use to boil something without heating. So that is by reducing the atmospheric pressure, right? By reducing the pressure that the liquid is feeling, right? So in this particular example, you can see this is a glass of water which is inside a vacuum chamber. So see, as the pressure is reduced, the liquid is getting boiled. And this is not by heating. This is done by lowering the pressure surrounding this liquid. So The liquid here, it is boiling because if you see the pressure of the air molecules that is around it, if it is reduced, if there is low pressure around it, so the liquid can start to boil. This is the method two of boiling something, right? So both are possible. This is something that is very common, but this is pretty less common, and you might have not seen it much. But this is also possible. So that is something very important when it comes to understanding what cavitation is. So see, what cavitation is, here we have a reservoir, and the reservoir is transferring fluid from here to here. It goes in the pump, right? And in this case also it is same. The reservoir is transferring the fluid to the pump, right? But the difference is that the reservoir in this case is on top of the pump, or we can say at a higher height or a higher level. And in this, the pump is on top and the reservoir is at the bottom, right? So this is ideal and this is not. Why? Because in this second case, the pump can start to have a problem known as cavitation. Why? See, the reservoir is now transferring the fluid and the pipes will be filled with hydraulic fluid already, right? And now when you turn on the pump will get this fluid, it will pump it out through this pipeline, right? But in this case, in the second case, what is happening is this due to gravitation, the fluid is not filled in this pipeline already, right? The fluid is not there. So what is there? Air. So air molecules are there in this pipeline, right? So if I turn on the pump now, what the pump will do, it will flush out the air molecules and will create something known as a vacuum in this pipe. Right? It will create vacuum in this pipeline. So there will be proper vacuum. And once the vacuum is there, what is vacuum though? Vacuum is any pressure that is lower than your atmospheric pressure. Right? So vacuum will be here, and vacuum, or you can also term it as a lower pressure, right? So low pressure will be here in this pipeline, and when this liquid enters in this low pressure, then what will happen? It will start to boil. As we saw in the previous example, that you can boil something by either heating or by reducing the pressure around it. So here there will be boiling of this hydraulic fluid in this pipeline. So the fluid will boil and will create bubbles. So that those bubbles, they tend to implode. Implosion is what, it is exactly opposite of explosion. Explosion is what, when it explodes outside. So there will be bubbles in this pipeline, and these bubbles, when they implode, that will cause damage, a lot of damage to this pump, because when these bubbles implode, they implode at a very uh, so it will cause bubbles in this pipeline, and when these bubbles they implode, they will produce a lot of shock waves, and these shock waves tend to damage the pump a lot. And these images that you are seeing here, these are little holes that are in the your pump. These are the images of damage due to cavitation. So these are little holes that are being uh, that has happened due to cavitation. And so this is the issue that so these holes that you're seeing here, these damages that you're seeing here, these are all due to the explosion of implosion of those bubbles. And this is something that can be avoided if you keep the reservoir at a higher height or a higher level than your pump, right? And that is why it becomes important. But on top of this thing, on top of keeping the pump at a high, on top of keeping the reservoir at a high level, you can also add uh, positive pressure on this particular side. Let's say I attach something. So these holes, these damages that you're seeing here, this is due to cavitation, and they literally the implosion are so powerful, so they produce very powerful what do you call it, shock waves, and that they damage the pump so much. And this can be avoided by keeping a positive pressure on the pump, right? So what you do is, this is your pump, and first of all you keep your reservoir at a higher level, right, as compared to the pump, so there is always some fluid in this pipeline. But the aircraft is again a very dynamic body. It can move here and there, and you don't want anything left out. So what you do is you also add a pipeline, and then you put your air pump over here. So a pump, or what do you call it, a cylinder filled with air. So this then pressurizes your hydraulic fluid, and this pressurized hydraulic fluid is then fed into the pump, so that the pump is always having a positive pressure at this part. Otherwise, there will be air, and the air will flush out. It will create vacuum, and the vacuum will then cause pump cavitation, and it will result to this kind of damages to the pump. And the cavitation, when it is happening, it creates a knocking sound. This is also some DGCA question, that it creates a knocking sound when you have pump cavitation. And it can be avoided by keeping a positive pressure on the pump. This is done by pressurizing the reservoir with the air pump. So this is an air pump, and you pressurize the reservoir with the air pump, so that there is always positive pressure on the pump inlet side. And then we have filters. So there are three types of filter. One is suction filter, then you have high pressure filter, and you have return filter. So these are very self-explanatory. Suction filter is a low pressure filter. Why is it called low pressure filter? Because it its purpose is to filter uh, the hydraulic fluid before the pump. So hydraulic fluid here is obviously at low pressure, right? So that is why it is also known as a low pressure pump. So what it does is, its purpose is to protect this pump, right? It is filtering the fluid that is before entering the pump. So fluid is coming from here, it is getting filtered here, and then it is moving towards the pump. So its purpose of suction filter is to protect the pump. It is also known as a low pressure filter because obviously it is filtering the fluid which are already at a lower pressure. The pump will pressurize it and move forward, right? And then you have a high pressure filter. High pressure filter, obviously, because it is your filter which is ahead of the pump, right, in the downstream of the pump. After the pump, you have this, which is your high pressure filter. It filters the fluid after the pump, and after the pump, where is it going in the system? So its purpose is to protect the system, right? So the suction filter does is it protects the pump, and high pressure filter does is it protects the system. Then you have a return filter. As the name suggests, when the fluid will return from the service, it will go to the return filter. The return filter will remove any other debris that is left, and that is picked up during the service. If I'm operating this particular actuator, so if during the service, if some debris are here, then it will take those debris and it will filter those debris before putting it in the reservoir. So there is one here, which is a suction filter, low pressure filter. Then you have a high pressure filter, and then you have your return filter. And some filters also have a bypass valve, which allows unfiltered fluid to pass through in case the filter is clogged. So with time, what happens is the filter is obviously cleaning the debris. So it gets blocked after some time. It should not happen during constant maintenance, but it can still happen sometime, right? So if the pump is blocked, now the fluid won't be able to go any further from here. It won't be able to go in this direction, right? Because the pump is blocked, the filter is blocked. So you attach a bypass valve. What a bypass valve does is instead of fluid going to the pump, the fluid will go from here, it will bypass, it will again enter the same line, right? And then it will go to the pump. So this is the purpose of bypass valve, that it allows unfiltered fluid. This fluid that is going through the bypass valve is not filtered, but since it is better to have unfiltered fluid in your system than to have no fluid in your system, right? If you are not able to operate your flight controls, then what is the use of what's the point? Like, if you're not able to operate the flight controls, you're not able to operate any services, any actuator, that is worse, right? Than to have unfiltered fluid running in your systems. What unfiltered fluid will do, it will damage your piston, it will slowly damage it, right? But if you're not able to move it, that is worse, right? So this is the purpose of bypass valve. Same valve is installed here also. If this pump gets blocked, the fluid can escape from here, go here. Even in the return filter, you have a bypass valve. This filters get blocked, then the fluid can move from here, can enter here, and can go back to the reservoir, right? And obviously, they will be having some protection here so that the fluid in normal condition when the filter is working just fine should not escape. So this valves will always open at a predetermined pressure so that when the filter is blocked, then only the fluid will go through the bypass valve. In normal condition, it won't. And there's just one point is filters are clean using ultrasound, and if ultrasound technology is not available, then you can use dissolving solvent. Is something extra you should keep in your head. Then you have accumulator. Accumulator is what it stores hydraulic fluid under high pressure, right? So accumulator, it stores small amount of hydraulic fluid under high pressure. But why do we need an accumulator? What is the purpose? So it prevents pressure fluctuation, it allows for thermal expansion and contraction, it provides a small emergency supply to system, provides initial pressure when the pump has just started. All these points you'll understand when you'll study ACOV. ACOV is what? Automatic cutout valve. So um, the pressure fluctuation that happens are again in ACOV, and the thermal expansion contraction can be explained here because see, hydraulic fluids are uh, temperature sensitive. So if you have a higher temperature, the fluid will tend to expand, and if the temperatures are low, the fluid will then contract. So the temperature fluctuations can be counteracted by already storing a hydraulic fluid under high pressure, right? This is your main line, this is your pump, this is your non-written valve, and this is going to the service. Now I have attached a accumulator over here. This is my accumulator in which there is gas and there is hydraulic fluid under pressure. So if the fluid, for example, in this line, it expands or it contracts. For example, there is cold outside and the fluid contracts, so there will be less fluid here, right? And then the system needs more fluid. What does it do? It asks the pump operates, and then it produces pressure, and then it sends it to the system. So this whole process, it takes time, and that is why the pressure will first drop. The pressure will drop, and then it will rise slowly, and then it will reach the normal system pressure. But we don't want that. We want a instant. We don't want the pressure drop to happen. We want, as the fluid contracts, there should be something that can immediately supply the extra fluid, right? So that's why we have this accumulator over here. So as, for example, a little bit of fluid contracts here, so this accumulator will provide the hydraulic fluid, and it also provides a small emergency supply during emergencies, obviously, because your reservoir is somewhere here and it is attached here. So, for example, this line gets blocked or it leaks, or the hydraulic fluid is empty now. So the hydraulic fluid is also stored in your accumulator. A little bit of hydraulic fluid is there, right? So it can provide its emergency supply in this case, and initial pressure during if the pump is failed. So it also provides the initial pressure on the pump has just started. So what happens is this pump it does not magically start to produce pressure. So, and the pump needs some time to load and rotate and then start to produce pressure, right? So it builds up the pressure slowly. And when the pump is building up the pressure and you select a particular service, so what will happen? The pump will slowly build up the pressure. The service will then, after some time, will be selected, right? So you don't want that to happen. You want instantly to be able to select the service. So when the pump is just started, the pressure will be provided from the accumulator to the service that you have selected, right? So when the pump has just started, provides the initial supply of pressure, and the pressure fluctuations are also prevented, that we'll see in ACOV. Rest of the points are covered here. And then we have a NRV that is fitted in the upstream of an accumulator to prevent backflow of the fluid into pump. Obviously, a non-return valve or a NRV is fitted here because see this fluid that is here is obviously filled in with the high pressure of air. So the fluid will tend to go in this direction and this direction too. This direction is fine. This is what we want. But what if it goes back in the pump? So that is why we have a NRV here. NRV is nothing, if you see it closely, you can see a ball and a spring. That is all a NRV is. So this ball, it will be pushed to the left hand side if there is hydraulic fluid flowing in this direction. So this ball will move to the left hand side, and what will happen? It will block the uh, just a second. It will block this vent by itself. See, if the ball moves here, it will block this particular part. Right, the ball will be like sitting like this, it will block this particular line. So the fluid won't move in this direction at all. But what will happen is the fluid will be able to move in this direction freely in this direction. So we want this to happen, right? Because the fluid will be coming in through this, and from the pump it will go like this. And will push the ball in to the right. So it will be able to move to the right easily, but it won't be able to move to the left. So there is an NRV, it is installed here, so to prevent the backflow of the fluid into pump. The thing that you need to remember is this, that the NRV is fitted in the upstream of an accumulator. Upstream is important here. So in your exams, there will be a question upstream, downstream, or where is it fitted? Right. In the NRV is fitted where, in upstream or downstream of the accumulator. So you need to select upstream, right? Because this is the upstream, right? This will be the downstream, right? Obviously, because the downstream is where the flow is supposed to go, right? And this will be exact opposite of it, upstream, going upstream, right? Upstream is what? Against the flow, no? So if waterfall fall is flowing like this and a fish is trying to climb up, so this is upstream, right? This is upstream going against the flow. And with the flow is downstream. So this NRV is fitted in the upstream of your accumulator, right? Then there is ACO. ACO is very important. It is a automatic cut out valve. What it does is it automatically returns the pump output back to the reservoir when the system pressure is reached. So this particular thing that you're seeing here, this is an ACOV. So Uh, what it does is it's written here. It returns the pump output back to the reservoir. So whatever the pump is producing, it will just take it back to the reservoir when the system pressure has reached. So see, ACOV was something that was very important in terms of. So next we have is ACOV, that is automatic cut out wells. So as the name suggests, it is automatic, and what it does is it automatically returns the pump output back to the reservoir when system pressure is reached. And how it works, we'll see that. But it was very important when it came to constant delivery pump or the fixed volume pump, if you remember that a constant delivery pump or a fixed volume pump always need to add two extra components, that is a ACOV and an accumulator. So why does it need an ACOV? So what ACOV does is it operates in two modes. There is a cut in mode and a cut out mode. So see, this thing that you're seeing here, this is the ACOV, and how it operates. So see, the hydraulic fluid is being filled, flowing from here. And it'll go to the pump. It will get filtered through here. What filter is this? Tell me. This is downstream of the pump, so this will be your high pressure pump, right? If there is filter installed here, it will be a low pressure filter, right? Now the fluid will flow from here. Now, what will happen is the fluid will. Alright, so how does an ACOV work? So ACOV has a piston. This is the piston that you're seeing here, right? And it senses the system pressure. So this piston senses the system pressure. How? This pipeline that you're seeing here, this thing will be having what? System pressure. So this pipeline will sense whatever pressure is being felt in the system, whole system, right? So, and there is this spring here and a poppet valve. Right? These three components forms an ACOV. So there is this piston which senses the system pressure, and there is this spring which is constantly pushing the piston downwards, and there is this poppet valve. And how does it operate? So see, if this system pressure being felt on the piston increases, so it will lift the piston up, right? If I'm applying pressure here, the system is applying pressure because the system pressure is being fed through this pipeline, right? And if the system pressure is too much, then it will lift this piston upwards. And what will happen is this poppet valve will open. The poppet valve will move upwards. I'll show you the image shortly. The poppet valve will move somewhere here, right? This thing will open up and this will create a vent over here. So the fluid will be able to move through this pipeline. Um, so how an ACV works is that it has a piston, and piston, this is the piston that you can see. This is the piston, and it senses system pressure. So this piston is sensing a pressure from this particular pipeline, right? And this particular pipeline is fed with system pressure. So system pressure is here. Whatever pressure is in the system, that is the system pressure, right? And the pressure is being felt on this particular piston. And then there is this spring that is constantly pushing the piston downwards, right? And see, if the system pressure is too much, if it's more than what the spring force, this is the spring that is constantly pushing it down, and the system pressure is trying to push it up. So if the system pressure is more than the spring pressure, what will happen? The piston will move up, and as the piston moves up, this poppet valve, it will also move up and will open this particular valve. And when the poppet valve moves up, that position will be known as cut out position, right? See, if the system pressure is more than the spring pressure, the poppet valve will open, and this is known as cut out position. And or else it will remain in cut in position. So this particular image that you're seeing, this is a cut in position, right? So the poppet valve is not moved, and it is in cut in position right now. So in this image, you can see that the poppet valve has moved up, creating a particular vent over here from where the hydraulic fluid can move or escape. See, in this particular case, the hydraulic fluid is coming from here, it is getting into the pump. Through the filter, it moves and Here, since the poppet valve is open, the fluid will move here. It will go inside the ACOV and it will move through these holes that has created due to the poppet valve moving up. And the fluid will then move in this direction. It will enter back the pump. So see, as the system pressure has increased, the system pressure is being fed here, and the system pressure is too much, and it has moved the piston up. So it has opened the poppet valve. And then what is happening? Whole hydraulic fluid is getting back to the reservoir. So the system pressure will then return to normal value, right? This is how an ACOE works. See, the system pressure is being felt by this piston, and if the system pressure is more than the spring pressure, the piston will move up. It will open the poppet valve, causing the hydraulic fluid to return back to the reservoir, and system pressure then reduces back to normal. And, and ACOV, see, ACOV, constant pressure change, constant, see. So ACOV was one thing that our constant delivery pump needed, or the fixed volume pump, right? Constant delivery of fixed volume pump needed one thing, that was ACOV. The second thing it needed was your accumulator. Why did it need an accumulator? Because see, there will be constant pressure changes in a hydraulic system, right? And there are obviously pressure changes because if you select a particular service, if you select multiple service, or there are small leakages, and there might be some fluid contraction, and there might be some expansion. So the pressure in the hydraulic system continuously changes. So these pressure changes might cause the ACOV to cut in and cut out again and again, right? What ACOV does, it releases the pressure if the system pressure is more than the spring pressure. It will open the poppet valve. It will send the fluid back, right? So this small pressure changes might cause the ACOV to open and close again and again. So this thing, what it will does is it will onload and offload the pump again and again, right? So to prevent this from happening, to prevent repeated switching on and off of ACOV, onloading and offloading the pump, we add something known as a accumulator. Accumulator we have studied already. Accumulator does is it stores some gas and hydraulic fluid, and hydraulic fluid is stored under pressure. So whenever needed, it sends out this hydraulic fluid into the system. So for small pressure changes, accumulator is there. It will balance it out. If the pressure is less, it will send it to the system and balance out the pressure. But for larger pressure changes, then only the ACOV will operate. Otherwise, ACOV won't operate again and again. Otherwise, it will be like on, off, on, off, on, off, on, because there are again and again constant pressure changes happening in the hydraulic system. That is why these two things are very important when it comes to a constant delivery pump or a fixed volume pump, right? So that is why we have an ACOV, an accumulator, and a constant delivery pump. In a fixed volume pump, obviously fixed volume, sorry, in a what do you call it, a constant pressure pump, the pressure is already constant. The pressure needs not to be maintained. So you don't need an ACOV or accumulator. Accumulator can be installed, but you don't need it, right? As much as you need in constant delivery pump. So and then we have actuators. Actuators are different from accumulator, but they might sound similar, but actuators are completely different. Actuator has a purpose to convert hydraulic pressure into mechanical movement. So whatever piston that we saw, those piston that were moving in and out, those are actuators, right? So actuator does is you fed in hydraulic pressure here, right? It will move the piston. So this hydraulic pressure is getting converted into your mechanical motion, right? So pistons are having three type. One is your single acting, and you have double acting unbalanced, and you have double acting balanced. All right, so single acting actuator. What it does is, as the name suggests, it is single acting. So it is hydraulically operated in one direction and spring operated in the other direction. So you have a piston over here. This is your piston, and you have hydraulic fluid on one side, and you have a spring on the other side, right? So one side, like this motion towards the left, will be done with the help of hydraulic fluid. Fluid will push it to the left, but if the hydraulic pressure is released, then the spring will push it to the right side. So that is how it is operated, and it is used in as a locking device in the landing gear up lock. So the obviously, because you don't want कि constantly hydraulic fluid supply करते रहना पड़ेगा when you don't want a service, like the landing gears in the, what do you call it, uplock position, when they're what do you call it, when the landing gears are in their retracted position. So you don't want कि constantly you need to supply hydraulic pressure just to keep it in up in the retracted position, right? So that is why the spring pressure will be able to keep it in that direction. For example, this side it would be, so they're generally used in as a locking device in landing gear uplocks locked by the spring, and when the pressure is released, it is unlocked. So yeah, in the landing gears, since they are locked for a very long time, and you don't want the hydraulic fluid to constantly supply pressure just to keep it in the retracted position, right? So the spring will keep it in the locked position, and when the hydraulic fluid is supplied, will then release, and it will be in the unlocked position or the down position, right? So single acting, one side is controlled with the hydraulic pressure, another side is controlled with the spring. It is used as a locking device, typically in your landing gears. And the uplock or the retractor position is locked by the spring and released by the hydraulic pressure. Then you have acting or double acting unbalanced hydraulic actuators. So this, as the name is double acting, both the sides will be operated hydraulically. So this is the piston, and this side also you have hydraulic fluid, and on this side also you have hydraulic fluid. So the hydraulic fluid is controlling both the sides, opposite to your single acting, where the one side was controlled by the hydraulic fluid and the other was controlled by the spring. Here you have both the sides hydraulic fluid. But why is it called unbalanced? Is because one side is this, right? It is the clean side. And this side, what do you have? You have a piston attached to this, right? You have a piston attached to this. So what it does is it becomes very interesting. See, since the piston is on this side and it is occupying some part of the area. So how much area do you have on this side? This much, right? How much area do you have on this side? This big of area, right? On this side, since this particular piston rod is attached, you only get this plus this. And on this side, you get this complete area, right? So what happens is due to less area, you will be able to apply less force on this side, and you'll be able to apply more force on this side. Why? Because force is what pressure into area, and pressure will be same felt here or in this or in this or in this, right? The pressure will be same, but the area is different, right? So you have more area on this particular side, so your force will be more on this side, and you have less area on this side because of this piston rod. The piston rod does not contribute for a area to be applied force, right? So this side will have less area and you have lesser force available on this side. So what what is the purpose of understanding this is that the services that require greater force are attached on the side of the piston rod that extends. See, on this side you have a greater area and you have greater force. right? So you'll be able to apply more force on this side. So the extension will happen with a lot of force. But since this side will have lesser area and lesser force will be applied on this side, so the retraction will be having lesser force. So this side, since you have more force, you can attach services that requires greater effort. For example, raising a landing gear requires more energy as compared to lowering it, right? When you lower the landing gear, you have gravity which is supporting it, but when you are raising the landing gear, you have what gravity opposing it. So that's why the raising a landing gear requires more effort that will be placed here. Raising a landing gear will be on this side because this side is getting more force, and this side, since it is getting lesser force, lowering of the landing gear will be attached on this particular service. Right? And similarly, we have double acting. What was I? Similarly, we have is double acting actuators. So double acting balanced, right? So this is the name suggests double acting. So the both sides will be controlled by hydraulic fluid and it is balanced. So piston rod is attached on both the sides. So both the sides will get the same area and hence they will have the same force. And it is used in services that require same force in both the direction. It is used in services that require same force in both the directions. So, example, in your nose wheel steering, and yeah, that is it in actuators. And then you have pressure control. So, in modern aircrafts, modern large aircrafts, they operate at a pressure value of 3000 psi. This is again a DGCA question that the modern aircrafts operate at a pressure value of what 3000 psi. But remember, modern large aircraft, they ask what modern small aircraft operate at. So it is at 1500 psi. So just remember these 2 points. And then we have some valves. So first is thermal relief valve. Thermal relief valve is if the temperature of the fluid increases, the fluid will expand, right? The temperature increase, the fluid expands. This causes an increase in the pressure, and this valve will open the thermal relief valve, returning excess fluid back to the reservoir. So whenever there is a pressure increase in there is a temperature increase in the line, the thermal valve does this. This would be the example. The thermal valve will be attached somewhere here and there is a, for example, some temperature increase due to any reason, right? There is a temperature increase, so the thermal valve will sense that it will send the fluid back to the reservoir. It is nothing, it's just as the name suggests, thermal relief valve. So whenever there is thermal, there is heat, it will relieve the pressure and it will send it back to the reservoir. Then we have is priority valve. Priority valve, as the name suggests, if the system pressure is not sufficient, like during a hydraulic leak, then the valve will send the fluid only to the primary services, for example, the flight controls. And it is also known as pressure maintaining valve. So this is something, for example, you have your reservoir, you have your hydraulic fluid, and there are two pipelines, for example, this and this. This is going to your primary services and this is going to your secondary services. So primary services are what that are primary for the aircraft safe function. That is your flight controls. So you cannot fly an aircraft without your ailerons, rudder, or your elevator, right? So that is the primary controls that are the most basic that you need in order to fly. Secondary would be your aircraft's flaps, for example, or the trim system, or your it can be it could be your flaps or trim systems, right? So these are the secondary. If you don't have these, it does not mean you're dying immediately, right? So in case of a hydraulic leak, for example, hydraulic leak somewhere here, and so the hydraulic pressure will drop and a selector valve would be installed somewhere here. So the selector valve does is it will block the hydraulic fluid. It will block sending hydraulic fluid here. It won't send it here. Instead of that, it will send the hydraulic fluid to the primary services only. It will seize those. It will seize the fluid in the secondary services. It won't let it go here. It will send all the fluid in the primary services. And this is only when the pressure is not sufficient, right? It won't do it unnecessarily. Then you have a non-return valve. As we have seen, non-return valve many times. It is something that allows full flow in one direction, but no flow in the opposite direction. It is also known as a check valve. So this ball, it allows the flow in this direction. This ball will move in this direction, obviously, and the fluid will continue. But if the flow comes from this direction, right, so the ball will move and it will cover up this hole, right? It will cover up this opening. So the fluid won't be able to move in this direction. It won't move in this direction. It will be blocked. So it allows full flow, right, in one direction, but it will allow no flow in the opposite direction, right? Then there is restrictor valve. So restrictor valve, as the name suggests, restricts the flow of fluid. यानी कि it restricts the flow of fluid. It does not stop it completely. So it will have full flow in one direction, but it will allow restricted flow in opposite direction. It will allow some fluid to flow through in opposite direction. So here, as you can see in this, the fluid that is flowing in this direction, right? It is being restricted by this particular opening. So you only have one small opening here. You can see closely. You'll see that there is just one hole from where the whole fluid is trying to escape, right? And why is it happening? Because there is a spring that is being moved forward. See, the fluid is coming from here, and the spring is moving in this direction only, and it will move this particular attachment. This particular attachment is all attached with the spring. So it will move this whole attachment to the left hand side, creating a small hole from where this fluid is escaping, right? So it will uh, go to the left hand side, it won't stop the flow, but in the left hand side, it will go restricted. Like there will be less flow in the left hand side, right? But exact opposite to that, if you move the fluid from here to the right hand side, then this attachment will obviously move to the right hand side because of the flow of the fluid. And then you can see there is one hole here, there is another here. I should change the pen. In this, you can see that the flow of the fluid is from left to the right, and it has moved this attachment to the right hand side, creating one hole here, one hole here, another one here. So you have a lot of holes here, but here you'll have only one hole. So there will be restricted flow in this direction, and there will be unrestricted or full flow in the opposite direction. That is what a restricted valve does. It is used in landing gear extension. Why do you want a restrictor valve in your landing gear extension? Is because during extension of landing gear, the landing gear can move down very quickly due to gravity. Obviously, gravity is already trying to pull it downwards. So during landing gear extension, it can happen very quickly. That's why you want a restrictor valve to slow down the landing gear going downwards, right? And you can see this particular clip here. The restrictor valve is restricting this flow, this particular flow that you're seeing here. It is being restricted, and when the landing gear moves up, the flow is not restricted. So the fluid will move from here, here, and here, here. So for downwards movement, there is restriction. For upward movements, there is no restriction. And it is also used in your flap retraction. So the flaps, when they're extended, they are feeling a lot of aerodynamic forces. Obviously, the air is flying at very high speed, and there are a lot of air moving over the flap surface. So the your restrictor valve is there. So when the flap are being retracted, there's a lot of air pushing it now. So when you're retracting the flaps, so it does not happen very quickly. That is why we have a restrictor valve there. And why we want it to not move so quickly, like if the landing gear just falls down, that is also fine. What is the issue? The issue is that it can damage the actuators. Right? If a particular service moves very fast, it can damage the actuators. And next type of valve is selector valve. Again, we have seen this thing many times. Selector valve is to select a service, and it directs the pump output to that service. All of those weird shaped valves that we saw, like these were what selector valves. And then you have a shuttle valve. Shuttle valve allows an alternate system to operate the same actuator in case of a normal system fails to supply the fluid. So this is the shuttle valve. This is the shuttle. This particular thing, it moves back and forth, and this particular part is supplying an alternate pressure, and this is supplying a normal pressure. So the normal pressure will be higher than the alternate pressure, obviously. Right, so the normal pressure is more, so the shuttle is pushed to the left hand side. The shuttle is here, right? So the fluid is entering here and it is moving out through this part to the surface. Now, in case the normal system fails to supply fluid for any reason, maybe there is a leak somewhere here or the reservoir is empty or something. So the alternate system, this particular part, it will supply the fluid. In this particular case, the alternate system is supplying the fluid and it has moved the shuttle to the right hand side, right? The shuttle is moved to the right hand side, and now the fluid is entering from the alternate supply and it is moving to the service, right? So the same actuator, it is not a different actuator. Here also you have the same actuator, here also you have the same actuator. So the actuator is same, but the supply is different. So in this case, the supply was here, and in this case, the supply is here. Supply is different, but it is operating the same service and the same actuator is used, right? Sequence valve is something that allows us to sequence operation. And for example, the landing gears should come down only after the doors has opened. So the landing gear doors need to first open and then the landing gear will extend. So if you want to sequence operation, we use what? Sequence valve. Then you have last is your hydraulic fuse. Hydraulic fuse, what it does, it acts like a bandage. So, for example, you have a particular pipeline over here. This is your fuse. So this pipeline will continue like this, it will go somewhere. So if, for example, the fluid is entering from here, it is moving like this, and there happens to be a leak. For example, the fluid starts to leak from here, right? So the fluid is leaking in high in much like if the fluid is leaking like too much, and so the fuse will do is it will just cease the operation. It will cease it from here. It will stop the flow. It won't let fluid to flow further. So what it does is we'll have a reservoir somewhere here. So the reservoir should not get empty just because of a leak in the in the lines. So it will stop the flow. It will block the line completely, and it is fitted in vulnerable areas like the brakes where there are high chances of leakages in the pipelines. And there is this question that is, why don't we use air instead of hydraulic fluid? Air, okay, so this is saying ki in when you are using a hydraulic fluid where you are storing the fluid in a reservoir, there is problem of leakages, there is problem of it catching fire, there are problems where the hydraulic fluid might create foaming, or there are a lot of problems, right? So why don't we use air? Air is in fact free. It is lighter than fluid, obviously, and it does not even require return lines. So in hydraulic fluid, what we were doing was we were having return lines for fluid. So when the fluid went to the pump through the service, and then we had a return line which will return the fluid back to the reservoir so that we can reuse it. But for air, it is abundant, so you don't have to return it. You can just release it to the atmosphere. You can just flush it, and you can just pump in new air, right? So you don't even need return lines in if you use air instead of hydraulic fluid, and it also does not catch fire. So these are all advantages that we'll get if we use air instead of hydraulic fluid. But why don't we use it? What do you think? So the only reason for not using air is that air is highly compressible, and hence it makes our system less responsive, and air will compress before it moves the piston. So if we have a piston and we are using what do you call it air if we are using air instead of hydraulic fluid, so the air here, since the air is highly compressible, what will happen if we try to like fill in air from here so that the piston can move outwards? We try to build up the pressure. So what will happen is first this air will enter, it will get compressed. It won't move the piston yet. It will get compressed. And when it will build a lot of pressure, then only the piston will start to move. So this is the issue, that air is highly compressible, hence our system will be very less responsive. Hence the air will compress, and then only it will move the piston. But some older aircrafts, they still use air instead of hydraulic fluid. There are some aircrafts that do use air instead of hydraulic fluid.
Alright, so we have covered complete hydraulic systems in the part 1 and part 2 combined, and that's it. And next we'll start with landing gears in the next video. I hope you're really liking the videos. Do let me know in the comments if you have any other feedbacks or any other doubts. Just comment down below. Alright, that's it. Thank you. Bye bye.